complete the example we did yesterday on 2D Mohr circle. Then we're going to do another example on 2D Mohr circle. Then this is going to follow by an introduction of 3D Mohr circle. Okay. So yesterday, what we did is we have plotted the principal plane orientation. Okay. So as you can see from this diagram over here, you realize that there's no shearing stress because it's at its principal plane. At the principal plane, shear stress is equal to 0. Okay. And then the next one is we want to plot the element. Okay, we are going to plot the element orientation. Okay, we're going to plot the element orientation of the maximum in plane shear stress. Okay. So yesterday we calculated the angle, which is 28.8. Okay, so the angle for the shear, right? So this will be equal to 28.8 divided by 2, and the outcome will be equal to 14.4 degrees. Okay, and then from X to where the maximum shear stress is, we are going to rotate the element. The angle of rotation is going to be clockwise, so we're going to do a clockwise rotation. So like what we had before, same thing. So I'm going to draw our original axis. Okay, so this is our x-axis, and then we have our y-axis. And then for this case, our element is going to rotate by 14.4 degrees clockwise. So I'm going to sketch a clockwise of 14.4, an angle of 14.4. Okay, so this is about 14.4. Okay, so this is the angle is rotating clockwise, 14.4. And let me take this. Take this. Okay. So at this orientation, right? So this is 14.4. Let me. Okay. At this 14.4, we are going to get a maximum shear stress. Okay. So I'm now will attempt to sketch the element, and then we're going to rotate the element by 14.4 degrees. Okay, so this is about 14.4 degrees, right? And then, like before, we're going to draw our green line. Okay. So from here, then another one. Okay. So we know that this is our originally, this is our X, right? And this is our Y. Okay. So when X is rotated from point X, you rotate 28.8, right? And you have a maximum shear stress. We know the magnitude, which we calculated. The magnitude will be equal to 570.635. But what direction is the element going to rotate? The element is going to rotate in a anti-clockwise direction. Okay, so anti-clockwise direction about this surface over here, right? Because this is rotated from point X clockwise 14.4, and it has to generate a clockwise rotation. So your shear stress will have this orientation, right? And that value over there will be equal to 570.635. Okay, so we will have 570.635 megapascal. And together, it also carries a shearing stress, normal stress, and we calculate the normal stress, which is equal to 75 megapascal in tension. Okay. So now if we look at y, okay, point y now, and when we rotate it clockwise by 14.4, okay, so this is point y, right? So we rotate over here, and this is rotate by 28.8. We realize that the element has to rotate in a clockwise direction. So for the element to rotate in a clockwise direction, it has to be in this, right? So you rotate in a clockwise direction. And likewise, it's seeing a tensile of 75 megapascal. Okay. So to complete the drawing, you just need to do this. And that's it. And if you have to draw the 75 down here, you can also. So this is your 75 megapascal, and your shear is 570.635 megapascal. So what we have learned is where for the element where with the maximum in-plane shear stress, we also can get what? Normal stress. Are we clear? Okay, so over here, we do get, if you look at the Mohr circle, we do get a normal stress value at our stress average. Okay. So one, we have done for the principal plane orientation. And the second one, the element orientation, where we have maximum in-plane shear stress. Okay. I'm going to do another example. Okay. And we're going to look at another element. And this is slightly different. Okay. So in this question, or in this example, so example number 1, we are going to determine the state of stress okay, uh, for an element okay, oriented 60 degrees okay, counterclockwise from the element shown. Okay. And we have to show the results on the element. Okay, we have to show the results on the element. So for this case, the original element. Okay, so I'll draw a transformation first. So we have X, and we have Y, and our original element okay. So now it had 560 MPa, and then we have 250, and then now we have negative shear configuration. So now this is at 400. Okay. So the first thing we do, we label this as our point X and our point Y. Okay. And what is given to us is stress X is equal to minus 560 MPa. We are also given that stress Y is positive 250 megapascal. And we have our shear XY, which is equal to shear YX. And this is at minus 400 megapascal. So it states that the element is rotate 60 degrees anticlockwise. Okay, 60 degrees anticlockwise. So we're going to rotate it 60 degrees. So I'm going to use my protractor. Okay. So at the end of the day, we are going to have an element that's rotated. So 60 degrees anticlockwise. So how it looks like is I'm going to now have put my element down here, okay, or put my ruler. So 60 degrees anti-clockwise, okay. So 60 degrees anti-clockwise or counterclockwise. Okay, so I'm going to sketch the 60 degrees now. Okay, so 60 degrees counterclockwise. Okay, so this is the 60 degrees line. Let me do it again. So this is our 60 degrees line. Okay, so 60 degrees anti-clockwise. Okay, so this is 60 degrees. Okay, from the element shown. Okay, so that is our angle. So we rotated from point or from Y. Okay, so we can call this line our Y60. Okay, we can call this line our Y60. Okay, and if you want to rotate, okay, from X, you can, okay, but if you rotate from X, right, it's going to be equal to, in this rotation, is going to be X30. Okay, so depending on where you're rotating from, if you rotate from the Y, you call it Y60. If you rotate from the X, it's no more 60, but it's X30. Okay, so now let's focus on, we are rotating on the Y60 because it's less confusing, because the question states that it's going to rotate 60 degrees clockwise. Okay, 60 degrees clockwise from your counterclockwise from your element. Okay, so now how about do we do this now? Okay, so we want to find the state of stress at 60 degrees counterclockwise rotation from the element shown. Okay, so now we are going to do that now. So from here, immediately, like what I told you, once you have these values, the most logical or the